is worth nearly $700 million annually to our national economy. On the North American continent, surveyors have laid out a grid enabling them to locate any point with respect to another within 30 feet. There are similar grids in other well-developed countries, but they are not tied together. A surveyor cannot see over the ocean with his transit to make the connections. But a satellite can. It is a valuable tool because of its altitude. Observers several thousands of miles apart can see a high-flying satellite at the same time. By making simultaneous measurements with optical and radio tracking instruments, they can determine just how far apart they really are. The current goal of satellite geodesy is to tie all geodetic grids together to within an accuracy of 30 feet. Using high-flying satellites as geodetic markers, the world's continents will eventually be tied together to one common reference system. Geodesists also hope to use their new techniques to keep track of polar ice caps and glaciers, monitor the geometry of the ocean surfaces, increase knowledge of how earthquakes occur, and make direct measurements of the rates of continental drift. As the world's population continues to grow, our need to develop, protect, replenish, and use our natural resources wisely becomes more apparent and urgent. The air and atmosphere are resources of the earth, as are the oceans, fresh water, ice packs, forests, minerals, and usable land. Efficient utilization of these resources not only includes their discovery and management, but also detection and control of pollution. In many areas, this need is reaching crisis proportions. Concerned citizens, private industry, state and federal agencies, all are seeking solutions to the problem. New techniques are being discovered to help. NASA has been exploring the use of both manned and automated spacecraft to develop the potential of flying instruments in space that will permit unique observations of the condition of our agricultural, water, forest, mineral, land, and marine resources. Much research has been done with aircraft, with information from existing satellites, and of course from the valuable photographs taken by the astronauts of the Mercury, Gemini, and Apollo programs. Based on this experience, it appears that the vantage point of space offers a number of unique possibilities for surveying Earth resources. The first two unmanned Earth resources satellites are planned for launch, one in 1972 and one in 73. They will provide a regular timber inventory of the Earth, identify crops, their vigor and yield, make automatic soil classifications, take photographs of the sedimentation flow patterns of the world's waterways, and help in locating mineral deposits. Here are some views recorded from planes and from Earth orbit by spacecraft. Better surveys of food and forest areas can be made from space, with computers distinguishing the conditions of the various types of crops and soils. Infrared photographs can show the onset of insect disease in forests. The damaged trees show up blue-green in color, the healthy trees red or pink. An Apollo spacecraft orbiting 150 miles over northern Australia spotted forest fires. Here are two others, as seen from space southwest of Tallahassee, Florida. By viewing fresh water from space, lake colors can be correlated with the biological, chemical, sediment, and pollutant content. Glaciers are another important source of fresh water, and their growth and decline are very sensitive indicators of the available supply. The Bureau of Commercial Fisheries says there is a close relation between fishery production and the temperature of the ocean, and they're very interested in having more accurate spaceborne instruments developed for monitoring these thermal conditions. This could significantly improve the efficiency of fishing fleets. Space photography can assist in mapping navigation routes in coastal and shoal water areas and help control silting in major harbors and navigable rivers. Ultimately, spaceborne instrumentation may permit observations of the wave heights of our oceans. Although it will not be possible to acquire all of the needed Earth resources data by sensors located directly in the satellites, it is possible to supplement the information by placing surface instruments, such as buoys, water gauges, and strain gauges, at strategically located positions on the surface of the Earth. These surface instruments could transmit the data to satellites, which would then relay it to central data handling stations. The Nimbus weather satellite is playing a role in ecology right now. A recording system on Nimbus was developed for an animal tracking experiment. Scientists attached a specially instrumented collar on an elk in western Wyoming. As Nimbus flies over, it receives information about the elk's condition and location and reports back to Earth. Accurate tracking of free-roaming animals in their natural environment will increase scientific knowledge of animal migration habits and may show ways to help protect our wildlife population. This is Skylab, America's first manned experimental space station. It will be launched into orbit around the Earth in 1972. There are several Earth observation experiments planned for the orbiting space station. One of the men who hopes to be flying in Skylab is scientist-astronaut Dr. William Lenore. He, too, is interested in Earth resources.
One of the more interesting aspects of what we can learn from space, I think, is the Earth resources area, which generally is tied up in the kind of things that I can learn from space by being in Earth orbit, looking back at the Earth from a remote sensing point of view. Meteorologically, we've seen many things already. We can learn about the Earth's surface from a crop survey standpoint, where the surface water is and the immediately subsurface water for the water management for the world. Pollution control and studies as to where the pollution is being emitted from and where it goes to. Fish industries for the ocean and sea states for ocean-going vessels, icebergs. I think these are just actually very few of the types of things that we can monitor and study from space on Earth's resources. The Skylab program is going to be stepping off in this direction.
Bringing space down to Earth continues to make a substantial impact on our way of life. Communications satellites routinely provide reliable telephone service on a global basis, and important events are brought into our living rooms through intercontinental television. Coming close to reality, satellites that broadcast news, educational and cultural programs to populations of entire nations. Meteorological spacecraft aid in daily weather predictions. Satellites for navigation and traffic control will help make better economic and safer use of air corridors and oceans. Earth surveys from space should offer another means of preserving natural resources. We are sharing many benefits from space right now. As we develop this potential in the future, applications from space will have continued, profound, and direct effects on our everyday lives here on Earth.